Welcome back, everybody. Today is going to be our first day of trigonometry. So some of you may have heard this word before, but trigonometry is a specific type of math where you study the relationships between the angles and sides of a triangle. So it's pretty much asking the question, if I have this angle measurement and these side lengths, what are the rest of the side lengths of a triangle going to be? So we need to start with a couple definitions and a couple ratios. So we're going to start with what is known as the trigonometric ratios. So there's three that we're going to talk about today: sine, cosine, and tangent. So when A is an acute angle in a right triangle, so the triangle needs to be both acute and right. So if we were to take the sine of angle A, and we use this image on the right to help you with this, it would be the length of the opposite leg over the hypotenuse. So the sine of A opposite side of A would be this side length BC, labeled little a, over the hypotenuse, which we know is going to be C because it's opposite the right angle. So opposite over hypotenuse, we would write the sine of A is A over C. Cosine of A is going to be the leg adjacent to the angle over the hypotenuse. So if this is the angle we're working with, the leg that is adjacent to it that isn't the hypotenuse is going to be B. Over the hypotenuse, we would write that as B over C. And now we are left with the tangent of A, which is the one where we're not going to use the hypotenuse. So tangent of A, we have the length of the opposite leg over the length of the adjacent leg. Adjacent will never be the hypotenuse. So we would write that as A over B. A very easy way to remember these ratios is the saying so, ka, toa. So is S equals O over H opposite over hypotenuse. Cosine equals adjacent over hypotenuse. Tangent equals opposite over adjacent. And then I would also highlight this as well. The hypotenuse never changes. It's always going to be opposite that right angle. The opposite is across from the angle, so A to A. And the adjacent is next to the angle, but not the hypotenuse. So for example 1, we're going to write the ratios for sine, cosine, and tangent of each of the given angles. So starting with the sine of G, so if we're starting here, sine, if we refer back, is opposite over the hypotenuse. So we have the side opposite G, so we have 15, and then 17, that's across from that right angle. So we'll have 15 over 17. All right, if we keep going, cosine of G, cosine of angle G is going to be 8. Again, 17, yes, it is next to the angle, but the hypotenuse will never be the adjacent. And then cosine is adjacent over hypotenuse, so we're going to have 8 over 17. And then tangent of G is going to be opposite, which we already said was 15, over the adjacent, which we just said was 8, so we have 15 over 8. Now, if these could be simplified, we would simplify them. None of these examples so far can be simplified, so for now, that would be the final answer. All right, now we are working on angle T. So if we're starting with angle T, we're looking for the sine, we'll start with the opposite. So now the opposite of T is going to be 8. Originally, 8 was the adjacent for G. Now that we're using T, it's the opposite over the hypotenuse. So that's going to be 8 over 17. Cosine of T, we're going to have adjacent, so 15 over 17. So we're left with, so we got 8 over 17 for sine, 15 over 17 for cosine. And now we are left with tangent of T. So we have opposite, which is 8, over adjacent, which is 15. So we are left with 8 over 15. All right. We are now going to apply that. Find the missing side. You might have to use Pythagorean theorem. We might not, though. And then simplify all the fractions. So starting with A, just looking at this triangle, yes, you could use the Pythagorean theorem, set up 3 squared plus b squared equals 5 squared, but from our lesson on Pythagorean triples, I see a 3, the hypotenuse is a 5, so I know that the third number in that triple is going to be a 4. All right, so now we're working with angle D. So we're starting here. Opposite of D is going to be 4. Sine is opposite over hypotenuse, so we did 4, and then the right angle right here tells us that 5 is our hypotenuse, so we're going to have 4 over 5. All right, cosine of D. That 3 is going to be adjacent to D, and then we already said that 5 is the hypotenuse, so 3 over 5 is going to equal the cosine of D. Now we have the tangent of D. We already said tangent was opposite over adjacent, and we said opposite and sine was 4, and that the adjacent and cosine was 3, so we are left with 4 over 3. All right, moving on to B. So we have a triangle with given lengths of 3 and 3. So we already know that this is an isosceles triangle, and from special right triangles, we know for a 45, 45, 90, 3, 3, this is going to be that leg times root 2 or 3 root 2. So this is where, as you can kind of see already, the numbers might get a little bit messier. So if we're taking the sine of angle D, we've got the opposite, which is 3, over the hypotenuse, which is 3 root 2. So we take 3 over 3 root 2. Get a new color real quick. That's written right here. But now we have two things. First off, we have a 3 and a 3 in the numerator and denominator. We can simplify that. And we also have a root 2 in the denominator, which we can't have. So let's first simplify those 3's. So they cancel out from the top and bottom. So we're left with 1 over root 2. And we're going to multiply both the top and bottom by root 2. So we are left with root 2 over 2. All right, moving on to the cosine of D. The adjacent side to D is also going to be 3, so we get 3 over 3 root 2 again. So we know from the previous problem, if we have 3 over 3 root 2, we're going to cancel out those 3's. We're going to multiply top and bottom by root 2. We are left with root 2 over 2. All right. Lastly, we have the tangent of D. So we said that the opposite is going to be 3. The adjacent is also going to be 3. So we have 3 over 3, and that simplified is just going to be 1. All right, moving on to letter C. First things first, we got to find this side length. So we've got our short side here. We've got our hypotenuse in 8 because it is across from that right angle. So let's set up 4 squared plus b squared equals 8 squared. So 16 plus b squared equals 64. If we subtract 16 from both sides, we get b squared equals 48. If we take the square root of both of those, that 2 should not be there, apologies. We are left with b equals 4 root 3. So if we look at this again, we now know this is a 30, 60, 90 triangle from our special right triangles lesson because the shortest side is 4, the hypotenuse is double that, and the longer leg is root 3 times greater than the shorter leg. So we are working with angle Z. So we're right here. So we're going to have sine is opposite over hypotenuse. So we have 4 over 8. That can be simplified down. That can be simplified to 1 over 2. Now we've got the cosine of Z. So the side adjacent to Z is going to be 4 root 3, and that is going to go over 8, which is the hypotenuse. So first things first, we can simplify the 4 and the 8. If we divide both of those by 4, the numerator is just left as 1, so we won't write anything. Denominator, we divide 8 by 4, we get 2. So we are left with root 3 over 2. And then we have the tangent of Z. So we already said the opposite of Z is 4. The adjacent of Z is 4 root 3. So we've got a 4 and a 4. We're going to cancel those out first, leaving us with 1 root 3. Multiply top and bottom by root 3, and we are left with root 3 over 3. The last two, pause the video for a moment, take some time, try and solve them, and then we're going to talk about it as a group. So, all right, let's talk about it. Sine of x. So first things first, we got to find that missing side length. So if we have 12 and 13, yes, you could also use the Pythagorean theorem, but guess what? This is another Pythagorean triple, and it's probably one of the more common ones of 5, 12, 13. So if we have sine of x, we're going to do opposite, which is 12 over hypotenuse, which is 13. So we are left with 12 over 13. Can't simplify that any further. The cosine of x, the adjacent over hypotenuse, so adjacent is that 5. Hypotenuse we already said is 13. We are left with 5 over 13. And then tangent of x, opposite we said is 12. Adjacent we said is 5, so we are left with 12 over 5. Lastly, we have letter E. So we have a triangle with a side length of 6. The hypotenuse is going to be 6 root 2, which means this other side length is going to be 6. We know that is a 45, 45, 90 triangle. Of course, you could use Pythagorean theorem to solve that, but we know that the hypotenuse is going to be root 2 times greater than the legs. So we're working with angle x. So if we were to take the sine of x, the opposite is going to be 6. The hypotenuse we said is 6 root 2. So we're going to have 6 over 6 root 2. We cancel those 6's, leaving 1 over root 2. Multiply top and bottom by root 2, and we get root 2 over 2. Cosine of x, now our adjacent is going to be 6. That is going to be over the hypotenuse again of 6 root 2. So we again have 6 over 6 root 2, which will be root 2 over 2. Tangent of x, this is the easier one. So if we do opposite, that's going to be 6 over adjacent, which is also 6. So 6 over 6 is going to give us 1. All right, so now we're going to talk about how to actually calculate what these ratios are going to give us. So here's a reminder of SOHCAHTOA. I would write that down in your notes or wherever you're putting this information. This is hugely important and will help you remember these ratios. All right, so because of similar triangles, trigonometric ratios are the same. We can use calculators to find the ratio of a certain angle, then solve that ratio. So we are going to use your calculators to estimate the value, round to 4 decimal places. Yes, that is a lot of decimal places. You will get pretty ugly decimals when you do these. First things first, calculators have to be in the degree mode. So if you are using a school calculator, in the top row of buttons, there is a button that says Mode, M-O-D-E. Click that button, and you'll see a bunch of words and numbers pop up on your screen. In the top row, you'll see the words DEG, space RAD, space GRAD. Make sure that the DEG is highlighted. That stands for degrees. That is how we're going to be solving these. So if we type in sine of 27 into our calculators, we're going to get 0.4539905. So we're just going to write that as 0.4540. Same thing if we do cosine of 48, we will get 0.6691. And then the tangent of 89 will give us 57.2900. Just double check that in our calculators once more. Yep, 57.2900. All right. So now we're going to put it all together. How are we going to use this to solve for side lengths? So use the trigonometric ratio to find the value of x round to the nearest tenth. So let's first identify the sides compared to the angle that we know. So we're going to be using this angle of 34 degrees. So the segment length that is labeled 8, we got to figure out what that is first. If we look, it is across from the right angle, which means this is going to be our hypotenuse. And then x, so we've got our 2 legs left, the horizontal one on the top, and then the vertical one that x is labeled. The one that x is labeled is going to be the longer leg, and we just know that by looking at it. So x is the long side. So we have the side length that is adjacent to our angle and our hypotenuse. So if we go back to our SOHCAHTOA, we know adjacent over hypotenuse is going to be cosine. So we circle cosine, and then we're going to set it up. The cosine of 34 degrees equals adjacent over hypotenuse, which is going to be x over 8. So let's first plug the cosine of 34 into our calculators. We will get 0.8298 equals x over 8, and then we're going to solve. So for a problem like this, when we have an unknown in the numerator and then a 8 in the denominator, let's multiply both sides by 8 to get x by itself. So we are left with 8 times the cosine of 34 equals x. So if we plug that into our calculators, rounding to the nearest tenth, we're going to get x equals 6. All right, we're going to do the same thing for this one. So we have our 36 degrees here. We're not going to fill in each blank this time, but we have this 20, which is going to be our opposite side, and then our x, which is across from the right angle, is our hypotenuse. So let's check this again. We have opposite and hypotenuse, so that's going to show up in sine. So we're going to use opposite over hypotenuse, so the sine of 36 degrees equals 20 over x. So to solve this one's going to be a little tricky. We're going to multiply both sides by x to get it out of that denominator. So we have x sine of 36 equals 20, and then we're going to divide both sides by 36, sine of 36. So we get, this is going to be a little messy, I apologize, x equals 20 over the sine of 36, and if we plug that into our calculators, we get that x equals 34. All right, now we're on to letter B. So we've got 55 degrees right here. We have the side that is opposite and the side that is adjacent. We know that this side here is going to be the hypotenuse because it is across from that right angle. So now we've got to figure out which ratio we're going to use. So we said we had opposite and adjacent, so we're going to use tangent. So the tangent of 55 equals opposite x over adjacent 33. To get x by itself, we're going to multiply both sides by 33. So we get 33 tangent of 55 equals x. Plug that into our calculator. We're going to get x equals 47.1. Okay, last problem. Fill in the blanks here, so please fill those in with me. So when solving a triangle means to find the measure of all the angles and the sides. So example 6, solve the triangle, round to the nearest tenth. So we've got our right angle right here, and we've got 61. So we know that the total angles in a triangle equal 180. So we can do 180 minus 90 in angle B minus 61 in angle C. So that simplifies to 29. So we know angle A is going to be 29 degrees. Now let's set up and find the rest of the side lengths. So I chose to start with the angle A. You could start with angle C. Either way, you're going to get the right answers so long as you set the ratio up correctly. So let's do sine of 29. So sine means opposite, because we have that 9. We need to use that because we don't know the other side lengths, over hypotenuse. So we're going to have 9 over b. Sine of 29 equals 9 over b. And then we're going to multiply both sides by b to get b out of that denominator. And then we're going to divide both sides by the sine of 29. So b equals 9 divided by the sine of 29. B is going to equal 18.6. All right, we're going to do the same thing for C. This time I chose to use the tangent of 29 because we'll have the opposite in 9 over the adjacent in C. So we have tangent of 29 equals opposite 9 over adjacent C. So we're going to multiply both sides by C to get C out of that denominator. So C times tangent of 29 equals 9. And then we're going to divide both sides by the tangent of 29. So we get C equals 9 over tangent of 29. Plug that into your calculator. We get 16.2. All right, that is all for today's lessons. If you have any questions, please contact your teacher or join a live session for help.